Good morning everyone. Welcome to the session of Embedded Systems, Sensors and Interfacing. So in yesterday's class, we have discussed what do you mean by embedded systems, and in further classes, we will be discussing about what is sensors and interfacing. So why we need a sensor and why interfacing is required with any other application. So now let us summarize what were the things we discussed in the previous class. So that is the definition of embedded systems. So as we all know that in our day-to-day activities, so we will be using more embedded systems, and with embedded systems equipped with all digital techniques. So in yesterday's class I told that what is an embedded system is. So where it consists of a hardware, software, as well as a mechanical device which also constitutes an embedded system. So where in case of embedded systems, so we have different technologies which are implemented with respect to any given embedded system. So where with or without our knowledge, so we will be using some embedded technology in your home automation system, or it could be with respect to your industry, or it could be with respect to your aeronautical or automotive, etc. So we have different types of applications where embedded systems are used. So this overall picture shows what are the application areas in which we are going to use, where in the yesterday's class we discussed about two applications. So one is with respect to air conditioning system, and one more is with respect to washing machine. So other than that, as you can see, so we have here numerous applications which are listed. So that is AC, where we discussed in yesterday's class. So we have refrigerator, then we have oven, microwave oven. So then we have a smart systems, then smart camera, then hearing aids, then we have automotive electronics. So these are some of the application areas where usually we use our embedded system. So now what is an embedded system? So it's just a revision of whatever we have discussed in the previous class. So as we already defined yesterday, so it's an electronic or electromechanical system. That means it doesn't consist of only an electronic component, but it also consists of a mechanical system also. That is the combination of electronic plus mechanical system. So it is designed to perform a specific function. So that means to say that, so it is used only to perform a specific or a single application like your washing machine or with respect to your air conditioning system. So along with that, as I already mentioned, it is nothing but along with a mechanical device, it's a combination of both hardware as well as a firmware, which is also called as your software. So now after knowing the definition of your embedded system and what are the application areas, now we should know some concepts like where the embedded systems are used and how it is different from other computing systems. So where we also discussed what are the criteria on which we are going to discuss how your embedded systems are different with respect to your general computing system. So general computing system came into existence with the general purpose computing requirements. General purpose computing requirements in the sense the general purpose application areas where we are going to use. So now other than that, so only a general purpose requirement was not sufficient. So later on we thought of having only specific application to be done. So that is with respect to your design of your embedded system, so the requirements can be satisfied. So that is the second point what we are highlighting, that general computing systems are not sufficient for the embedded system requirements. Next, the third one is the embedded computing requirements demand something special. So that means how it is unique, how your embedded system is unique, that is in terms of its response time, and then the real time, that means it has to perform its operation in real time, then the power consumption, that is nothing but the efficiency, the accuracy as well as the memory requirement, etc. So these are some of the points what we are going to consider whenever we want to distinguish your embedded system with respect to your general computing system. So as you can see, so in yesterday's class also we discussed about all these criteria. So where what are the general points to be considered with respect to the your general purpose computing system as well as with respect to your embedded system. So where in case of the general purpose, what are the components present? So that means it consists of a general purpose operating system, hardware and software. In case of embedded system, it might contain an operating system or as well as it consists of an hardware as well as the software. Next, in the case of general purpose computing system, so the operating system what we use, it is general, in general, which we can use for multi-purpose application. But in case of embedded system, as I told that it might contain an operating system or not. So that depends upon what type of application we are using. Depending upon that, we can implement an operating system to your embedded system. Then third one is it is user friendly. That means in the case of general purpose, it is alterable. That means you can alter the hardware and software and you can reuse. In the case of embedded system, so we cannot do the alteration because it is designed for only a specific application. Next, we have the performance criteria where, so performance wise your general purpose computing is faster, but here compared to your embedded system, so here your embedded system performance is performance as well as power consumption, memory usage, those are the deciding key factors what we are going to consider in case of embedded system. But in the case of general purpose computing system, so only the speed is considered here. And next, in the fourth point, we have the power management, that is the power consumption. Power consumption is more here and power consumption is less. And the next is the response time. So the response time means how quick your system is going to respond. So response time is not time critical, that means it is not mandatory that it should meet its requirement within the specified deadline. But in case of embedded system, it has to meet or it has to be critical, that means it has to respond very quickly. Then it not the next criteria is it need not be deterministic in execution behavior. That means any for execution of any output, it could not be deterministic. That means it is not hard real time bound. But in case of embedded system, it is hard real time bound. That means it has to perform its operation. That means missing of any particular event is going to cause damage. So that's why in general purpose computing system it is not deterministic, but in case of embedded system it has to be deterministic. So these are some of the points where we are going to distinguish your general purpose computing system with respect to your embedded system. So the next topic is classification of embedded system. So where we are going to classify your embedded system based on these four criteria, that is based on generation, then based on complexity and performance requirement, and the third one is based on the deterministic behavior, whether it is deterministic or non-deterministic, and it is based on triggering. So let us discuss one by one. So how these embedded systems are being classified first based on the generation. So now based on the generation, so we have the four generations of embedded system, that is first generation, second, third, fourth, as well as the next generation is nothing but the fifth generation which is running at present. So that is nothing but the 5G technology what we are using at present with respect to our smartphones as well as with respect to your internet, Wi-Fi, etc. So now in the case of first generation, so we have embedded systems which are built just with 8-bit processors, that is microprocessors, that is 8085, and 4-bit microcontrollers, that is Z80. So these were the two controller as well as the processor which were used in your first generation. So now coming to the hardware requirement as well as the software. So it were simple and it was not very much complex, and the program was written in the assembly code. For example, your digital telephone keypad, stepper motor control units. So these are the inventions of first generation. So next, coming to the second generation, so we have more advanced microprocessor and microcontroller, where the size of, that is the bit handling capability of both of them have been increased in the second generation, that is with 16-bit microprocessor and 8-bit, or it could also use 16-bit microcontroller, and the complexity with respect to your instructions were also increased a bit higher, where we have more complex instruction set compared to the first generation. And in case of your second generation, the OS operating system, so they were also used for the operation with the embedded system. So for example, your data acquisition system, that is for acquiring any data like weather forecasting, and SCADA systems. So these were some of the devices which were used with respect to your second generation. Next, coming to the next third generation. So where in the third generation, again the bit size was increased further with 32-bit and 16-bit microcontrollers, and then more advanced processors were developed in this generation, that is like your DSP, that is digital signal processor, and application specific integrated circuits. So these were the more advanced processors which came into existence in your third generation. And next, the complexity of handling the instructions was also more in case of your third generation, and the pipelining of the instruction also came into existence in the third generation. And here we have dedicated real time and general purpose operating system. So in the previous generation we have just introduced operating system, but here in the third generation we have some deadlines to be met which has to be performed in real time, as well as a general purpose OS was developed. Then in case of this, so what were the advancements was, it was used in robotics, then in media, and in case of networking, so computer networking. So as the processors were advanced and the bit handling capability and the complexity of instruction handling increased, so the application wise it also increased in the areas like robotics. So then coming to the fourth generation, so in case of fourth generation, as you can see, so we have system on chip which came into existence. That means system on chip in the sense you need not have to interface numerous devices to your IC, that is for example, if you are using a microprocessor, then you need to have interfacing of, or you need to interface externally the devices like timers, counters, then DAC, etc. But in case of your controller, so you need not have to interface all these devices externally, where the system on chip reduces the complexity of interfacing these devices. So with the help of this SoC, so the performance level as well as the complexity involved in designing was also reduced with respect to your fourth generation. So the complexity of handling the instructions as well as the programming of instructions were also made simpler in the case of your fourth generation, and also the processing speed was increased in the case of fourth generation with respect to real time embedded operating system. So where in the case of third generation we have general purpose operating system, but in case of fourth generation we have embedded operating system which is used for a single dedicated application which can perform its operation in real time at a very faster rate. So for example, at present what we are using, that like your smartphones, then your MIDs. So these are the implementations or advancements or the application areas where your fourth generation was used. Next, the next generation, so it is nothing but the present generation what we are now. So where we have embedded systems are have played a major role in many application areas, and we have the next generation is nothing but the 5th generation what is running now. So where the data movement, or it could be with respect to the processing speed, has been increased compared to the 4th generation. So we have fastest processing speed, as well as processing of instructions are taking place at a very faster rate, as well as it operates with respect to real time when compared to the 1st generation, as well as with respect to the 2nd, 3rd, as well as with respect to the 4th generation. So whatever the data we want to send to a farther distance, so that can be done easily with respect to the present technology, that is the 5G technology. So that is related to the classification based on different type of generations. So next we have the complex based on complexity and performance. So that means how faster your system is performing its operation. So where we have 3 classifications here, that is small scale, medium scale, as well as large scale embedded system. So let us discuss one by one. So where in the case of small scale embedded system, so we are using in simple applications, and we are not bothered much about whether it is performing at a very faster rate or a slower rate, but we are using it to perform its operation. For example, the electronic toys, so which are used by the children. So that is a simple example for this small scale embedded system. So where here we are using just 8-bit or 16-bit microprocessor, as well as microcontroller can be used, and as you can see the performance is very less, and it might contain or it may contain an simple operating system for performing the function with respect to a small scale embedded system. So the next is medium scale embedded system. So where we have an increased complexity with respect to your hardware and software, as well as, so why the complexity increase now? Because so the number of bits what we use for programming or processing of the instructions has also been increased here. So that is from 8-bit it has been increased to 16-bit, or it could use 32-bit. 16 or 32-bit can be used, where the fastest processing like digital signal processors came into existence with respect to your medium scale. And also here the embedded operating system which performs its operation in real time came into existence in the medium scale embedded system. Okay. So next is the third one is large scale embedded system. So where in the case of large scale, the complexity involved with respect to your hardware and software increased, as well as the performance also was increased compared to the rest of the two. Why? Because the that is your using a 32-bit as well as 16-bit RISC processors. So RISC in the sense reduced instruction set computing processors, where you have the size of instructions is being reduced. So with few instructions you are programming, and the complexity involved with programming is being reduced here. And also we have system on chip, that is reconfigurable system on chip. That means you can reprogram your chip. That means you can use your system that is you can use for numerous applications, as well as programmable logic devices, that is PLDs. So you can reprogram and you can use it for multi-purpose applications. Then decoding and encoding of media, cryptographic functions. So these are the things which were implemented with respect to your large scale. And also here we have real time, that is high performance real time operating system was used. So because the task has to be done within the specified time, and that is you can have task scheduling, that means which task has to be completed with respect to what time, and also the priority, which among numerous tasks which task has been given the first priority. So that all management of those priority levels as well as the assigning of task scheduling, everything was done with respect to this large scale embedded system. So this is about the complexity as well as the performance. Then we have based on deterministic behavior. As I told, deterministic behavior means, so you have to do that particular work within the specified time. So that is, it is applicable for real time system. For example, in case of monitoring a patient, so related to his health, like your ECG monitoring or you're performing a scanning operation, so that has to be done real time. So that has to be deterministic, that means it has to do its proper work. So here also we are giving much importance to that, that is real time behavior. That means the task has to be completed within the specified time. So if it performs its operation in at a particular time instant, so then we call it as deterministic, and if it does not perform its operation, so then we call it as non-deterministic. So now based on the execution, so we are going to call it as hard real time as well as soft real time systems, where hard real time systems are deterministic and soft real time systems are the one which are not deterministic. That means it is going to meet its deadline within the specified time. Here it is going to miss the deadline or your task is going to be delayed. So this is about the deterministic behavior. So next we have based on triggering. So based on triggering, so embedded systems which are reactive in nature, like a control system in case of industrial control applications where you are going to control the opening and closing of a valve. So that is whether it is event triggered, that means the reactive systems can be either event triggered or time triggered. So that means when your embedded system is going to perform its operation, that means triggering in the sense only when certain conditions are met, so it is going to perform its operation. Like event triggered in the sense when certain event happens, like certain time has met, so it is going to perform its operation. And time triggered is nothing but, so when some time interval like 10 microseconds has been allotted for that particular event to be completed, if suppose that 10 seconds has been completed, so then that is called as your time triggered. So that means it is, if it meets some criteria, so then only that event is going to happen. So that is nothing but triggering refers to whether it is going to satisfy its condition, so only when certain criteria are met, so that is called as your event triggered or time triggered. So these are the 4 different classifications of your embedded system. So next is the main application areas where we are going to use our embedded system. So like consumer electronics. So in the case of consumer electronics, like your digital cameras, then your video recorder, that is nothing but your camcorders. Then in case of household appliances, that is in our home, we will be using these devices, that is without TV, we cannot survive. So then washing machine, fridge, microwave oven, so these are your household appliances what we necessarily use in our day-to-day activities. Then home automation system and security system. Home automation system in the sense like your sprinklers, your fire alarms, these are your examples of your home automation, that means the one which provides security to your home. Then automotive industry, like in case in your car, so we have your car, the cars which are now manufactured are fully automated, like we have ABS system, that is automatic braking system, as well as ignition system. So we have different types of systems which are now developed with modern cars. Then in case of telecommunication, so that is in case of your cellular phones, telephone switches, then multimedia applications. Then in case of computer peripherals, that is in case of your printers, scanners, etc. Then computer networking system, that is in case of your servers, then your firewalls, So all those are implemented with respect to your embedded system. Then in healthcare monitoring system, so where as I just mentioned, scanning, then ECG machines, etc. Then in case of your instrumentation, so like multimeters, so where we have digital multimeters, digital CROs, then PLC systems. So these are all the examples, common application areas where we are going to use our embedded system. And in the case of banking systems also, that is in case of your ATM machines, so we are going to use. And then card readers, so card readers were nothing but where in case of your, if you might have seen in a supermarket, so they are going to read what is the price of item, so that is by scanning the barcode. So there also we are going to use your embedded system. So next topic is related to elements of an embedded system. So as you can see the picture, so we have numerous elements which are present with respect to any given embedded system. So of course the common things what we have is an input device, an output device, and a processing or what we call as a controlling unit. So here also with respect to our embedded system, as you can see, we have an input IO ports, so all your input devices what we consider. So those are nothing but we can also call them as the sensors. That means we are going to sense the input, and whatever the input we are going to sense, that is given to your core. Core is nothing but the processing device what we use. So the core, so what we are using with an embedded system, it can be a controller or it can be a processor. So or it could have both of them in some of the applications like your digital camera. So you can have a processor as well as a controller, both can be coordinated and it is going to perform its operation. So then whatever it is going to process, so that is being outputted. So the output what we call it as actuators. That means suppose if I am sensing something at my input end. So if I want to sense what is the temperature of the room, that is sensed with respect to a temperature sensor. So now whatever the temperature it has been sensed, that has to be indicated at your output end with respect to a display section, or it could be any output devices what you have connected like an LED, or it could be with respect to a buzzer, or it could be with respect to an LCD. So where you can show what is the indication of what has been sensed with respect to your input after it is being processed with respect to a controller or a processor. Along with that, so we have, suppose if you want to store anything, like your program has to be stored before you execute it, so where we will be using a memory unit. So where your memory unit, it can be a ROM memory or a RAM. So depending upon what type of application you are using, so we are going to choose the size of the memory. So that is about the one more device what we are going to use. So as I told, the core, it could be an microprocessor, or it could be a controller, or it could be an system on chip, or it could be a digital signal processor, or it could be an application specific integrated circuit, or it is a field programmable gate array. So any of these can be used for your system core. Next, other than these main devices like input, output, processor as well as memory, so if you want to have any external interfaces to be connected to your embedded system, that can also be connected. So like, so we have communication interface. So like if you want to connect an USB, so then that provision is also made here. Then other than your communication interface, we also have other supporting integrated circuits and embedded system. So other supporting integrated circuits and embedded system and subsystem in the sense, so if suppose if you want to display your data, then you can have an LCD interface to it, or if you want to have a stepper motor to be interface, so that can also be connected. Or if suppose if you want to scan, or if you want to print anything, so those devices can also be connected to your embedded system. So these are some of the elements, or I can say that the main elements which are to be present with respect to an embedded system, that is an input device, an output device, then a memory unit. The main is the main heart of your embedded system is your system core. So where core, it can be any one of this, and other than that, if you want to have an additional facilities to be connected, so that can also be interfaced depending upon what type of application you are designing your embedded system. So as I just told, so it consists of a processor, controller, that is FPGA kit, then you can be a DSP, or it could be an application specific. So then that is about what are the elements which are present with respect to your embedded system. Then we have what we call as the differences with respect to RISC and CISC processor. So what is this RISC and CISC processor? So RISC and CISC processor is nothing but it depends upon how many number of instruction handling capability your controller or processor has. So RISC stands for reduced instruction set computing, and CISC stands for complex instruction set computing. So we will continue further, that is with respect to differences of your RISC and CISC, and the differences with respect to microcontroller as well as microprocessor in the next class. Thank you.